So let's take a look at our learning goals. You should be able to draw ray diagrams for convex mirrors, and you should be able to describe images produced by convex mirrors. Now, unlike the concave mirrors, there's only one location that the image will be located in. So it will be on the side of the mirror, and it won't be anywhere located between F and C or between V and F or at F or any of those locations. It's just going to be in one place on one side of the mirror, which means all of our rules will be the same for every single time we draw the diagram. So that makes it a little bit easier for us. We don't need to memorize as many rules. However, these diagrams are a little bit more complex than some of the ones we saw before, so make sure you're paying close attention. Now, like last time with the concave mirrors, I can't draw these on my tablet because I can't get the angles correct and make everything nice and clean and easy to understand. So I'm using animations as if that was what I'd be drawing on the tablet. So let's start off here with our object. We have a blue balloon next to a mirror. Our first rule is that an incident ray going towards the mirror will reflect off of the mirror as if it had come from the focus. So we know that with convex mirrors, the light rays are going to separate when they come off of the mirror. So it's going to leave the mirror, the reflected ray will leave the mirror as if the ray had come from the focus. So we'll see what that looks like, as if it came from the focus. Now remember, light does not travel through the mirror, so the light isn't actually coming from the focus. The light is coming from somewhere beyond that balloon, but it looks like the ray came from the focus. Our next rule is that light traveling towards the center of curvature will reflect back along the same line. Just like what we saw last time when we used the rule with the center of curvature, we need to put an arrowhead in each direction on that same line to indicate the light going in and coming out is along the same line. With our other rules, there's just one arrowhead for each line, but here we need to draw the arrowhead to show it's going both ways along the same line. And again, the light is not actually coming through to C because the light cannot travel through the mirror. So we draw our dashed lines to indicate that the light is not traveling through the mirror, but that it looks as if it came from the center of curvature. Now, if we look at our diagram, we can see where the rays cross. The reflected rays actually separate from each other, but when we back it up on the other side of the mirror, we can see that they cross somewhere between V and F. Since our rays started at the top of the balloon, where they cross will also represent the top of the balloon, and since the string of the balloon went straight down to the principal axis, the string of the image balloon will go straight down to the axis, and this is what our object will look like. Now, if we're describing our object, it's smaller than the original, it's upright because they're facing the same direction, it's located between F and V, and it's a virtual image because it's on the opposite side of the mirror from the original object. And this will always be true for every single type of image you do in a convex mirror. So convex mirrors have the same rules and have the same description every time. Here are the rules listed for you if you'd like to write them down, so you can pause the video and do that, but I'm not going to read through them now because I've already explained them. So let's take another look at our learning goals. You should be able to draw ray diagrams for convex mirrors, and you should be able to describe images produced by convex mirrors. If you can do that, fantastic. If not, please rewatch the video.